Hello friends, today we are going to learn the concept of maxima and minima. Since origin of life, everybody has used and talked about the concept of maxima and minima even without knowing the concept of maxima and minima. So let us see just the history of maxima and minima. The great scientist Sir Isaac Newton has invented this concept of maxima and minima. So now before proceeding with the examples, let us see some of the daily real life examples in our life, routine life. So in the first example, kings. In early age, kings used to estimate the concept of maxima and minima of army to calculate the army of opposite side. In the second example, doctors. These doctors used to record the concept of maxima and minima to analyze the symptoms of any disease and cure the patients as soon as possible. In the third example, cooks. Cooks used to estimate the maxima and minima for the calculation of quantity of food. Now in the fourth example, businessmen used to calculate and estimate the maximum and minima for profit and loss happened in every transactions, so that they can do the business more better. Now in the fifth example, women in the house, they prepare food according to the maximum and minimum consumption of each individual, so that the food is not overcooked as well as insufficient. So these are some of the real time examples. There are lot many examples using the maxima and minima. This maxima minima concept is also used in mathematics. So in mathematics there are some applications in linear algebra as well as in game theory. So friends, let us see some of the mathematical examples in the maxima and minima topic. So friends, maxima and minima represents the extreme values of any function. Extreme values means either largest possible value or the lowest possible value. So let us see one by one the concept of first maxima we will see, then we will see the concept of minima. So in the concept of maxima, maxima is nothing but it is the upper bound of any function or the largest possible value of any function. F of a, this is the condition, f of a greater than or equal to f of x. So this is for all x in the domain of function, then this f of a will become a maximum value. So here we will see one example. So in this example, see f of x is a one function, and for this function, given function, let us find out the maximum value. Okay. So f of x is equal to minus 16x square plus 32x plus 6. So for this function maximum value we get 22 at the x equal to 1. But how we get x equal to 1 and how we get the 22? Let us solve it togetherly. So for this given function, let us find out, let us take the derivative of the function for finding the value of x. So taking the derivative, f of x derivative is f dash of x is equal to, for this term derivative, minus 16x square derivative is minus 32x. For this term 32x derivative is plus 32, and for 6 it will be 0. So this equation we are equating it to the 0, because by equating it to 0 we will get the value of x. So 0 is equal to minus 32x plus 32. So for this whole equation let us divide it by 32. So by dividing it by 32 we will get the value of x. So 0 is equal to minus x plus 1. So value of x becomes 1. So we got the value of x as a 1. So we will put this value of x as a 1 into the above equation, our given equation. So by putting this value, let us solve it. F of x is equal to minus 16 into 1 square plus 32 into 1 plus 6. So let us solve it. Minus 16 plus 32 plus 6. 32 plus 6 is 38, and minus 16 plus 38 is 22. So for this f of x we got the 22 value as a absolute maximum value of the given function f of x. So this is the concept of maxima Friends, in the concept of graph, the highest peak point, highest value of the graph is nothing but the maxima of the graph. So hope you have understood the maxima. Now let us see the minima. So for minima, exactly opposite of maxima, so it is nothing but the lowest possible value, or it is also called as the lower bound of the any function. So for this minima, we have a condition. So condition is f of a less than or equal to f of x for all x in the domain of function, then f of a will become a minima. So friends, similarly we have solved one example for the maxima. I have taken here one example, f of x is equal to 32x square minus 32x minus 6. So with the same method, answer for the minima will get the minus 22. So minus 22 is the minimum possible value for this given function f of x. Now let us see how to calculate the maxima and minima of any given function. So let us see an example. So in the example, there is a box. So this box is with a square base and an open top, and this box has a volume of 32 cc. So for minimum area of material, what is the dimensions of box? This is the problem statement. So to solve this problem, let us consider x is the base of the box and y is the height of the box. So I have written here, let x be the side of square base and y is the height of the box. Now you know what is volume, formula for the volume. So volume is equal to length into breadth into height. So here V is equal to length is x, breadth is x and height is y. Therefore V is equal to length is x, y, so it became x square y. So volume is given already in the problem statement, that is 32 cc. So we have written here 32 is equal to x square y. So value of y becomes 32 by x square. So let us note this value of y as a 32 by x square and let us proceed further. So you know what is a formula for the calculation of surface. So surface area is equal to, see, x square because this there is a base with x is the length and breadth with the x. So x into x becomes x square, plus there are 4 sides available with the box. So this 4 sides are x into y into 4. So it became 4xy. So surface S equal to x square plus 4xy. So in this equation we can put value of y as a 32 by x square. So putting this value, I got the function f of x which is equal to x square plus 4x. Instead of y, I have replaced it with the 32 by x square, which is equal to x square plus, see here, 4 into 32, it has become 128 divided by x square, but here x and x square, so it will remain as a x. So f of x which is equal to x square plus 128 divided by x. Now we will find the critical point by finding the first derivative, and after finding the first derivative of the equation, we will is equal to 0. After equating it equal to the 0, we will get the value of x. So let us do the same. So first derivative of the equation f of x, that is f dash of x, which is equal to derivative of x square is 2x and derivative of 128 by x is minus 128 by x square. So we have written here. So equating this equation which is equal to 0, we will get the value of x. Equating this equation which is equal to 0, we will get the value of x. So this equation is 2x minus 128 divided by x square, which is equal to 0. Here we will take the x square term as a common term. So this term will become 2x cube minus 128, which is equal to 0. Now this minus 128 we will shift to the left hand side. So this becomes 2x cube which is equal to 128. Now x cube which is equal to 128 divided by 2, that is equal to 64. So x cube is equal to 64, therefore value of x becomes 4. So we have one equation for y is equal to 32 by x square. So here we can put the value of x and we will get the value of y. So putting the value in the same equation, y is equal to 32 divided by x square, that is 32 divided by x is 4. So 4 square is 16. So 32 by 16 becomes 2. So value of y is 2. So we got the critical point 4 comma 2 because value of x is 4 and value of y is 2. So for this critical point 4 comma 2, let us check the maximum and minimum value. To check the maximum and minimum value, we have to find out the second derivative of the function. So finding the second derivative of the function, so function is f dash of x, second derivative becomes f double dash of x, which is equal to second derivative of 2x, that is 2, plus minus 128 divided by x square becomes plus 256 divided by x cube. So in this equation we have the value of x. Value of x is 4, we have recently calculated. So putting the value of x as a 4 into the equation, we get this equation which is equal to 2 plus 256 divided by 4 cube. So this whole value becomes 6 and 6 is greater than 0. So when the value of any function which is greater than 0, then function has a minimum. Function has a minimum when x is 4 and y is 2. So friends, hope you have understood the maxima and minima calculation.